Okay, I'm start talking about the guitar. I have one here in class. People at home can't see this, of course, but my guitar. First of all, I am not a guitar wizard or anything, but I can play a few chords. And when you play a chord, the notes that go together, they all sound kind of good together. And if you like mess it up, it's pretty easy to tell that you've like, played something that wasn't meant to be a chord. You think that goes together? I don't think so. Because certain combos sound nice and other ones don't. Now, and the ones that sound nice together are all fractions of the same original key. Let me give you an example. The top string, if I pluck that string, I get a note. If I want to replicate that same note except higher up, that would be one octave higher. How much of the string do you think I should cut off? Like, I'm going to push down on the fret here, it's called, and then pluck it again. But you'd think that it would just be like, some kind of random distance along here that I would pluck, but it's actually very accurate. To get the next note up, exactly one octave up, this string, which is 25.5 inches long, take a wild guess. How many inches or what fraction I should have to push down on to get the exact one octave up? Any idea? It's really simple. The whole thing's 25.5. What fraction of the original do you think gives you the next note up, one octave up? All right, it's really simple. A half. So if I go half of the 25.5 total inches here, and I go half of that, it's going to be 12 3/4. Can you see where 12 3/4 is on here? Can you see that there's a fret right there? A little silver thing. Okay. So at 12 3/4 is exactly half of the length of the key. So if I take and pluck it, and then I push down on that fret that's exactly making it half the length it used to be, see how it's the same exact note? Just up an octave. If I take this other string, normal sound, and I hit it at exactly half its normal length, you get what I'm doing here? It's exactly one octave up. And the fact that it's exactly halfway is kind of cool. What do you think happens if I go halfway between the halfway and the end? That'll be a 3/4 length string. That one sounds good with the first one. And if I go, missed it. Nope. Let's try again. Does that sound like a chord a little bit? You could play with your hands on a piano. It's because I'm at halfway and 3/4, and the next one up from that, the one that was the longest fret that I pushed on, was at 4/5 or 0.8. The fact that they came out to exactly whole numbers, I think, is kind of cool. And the fact that when you play a chord, you can tell if you're doing it right. That sound better? Because they are all going to be fractions of each other. And they're whole numbers, too. So the Pythagoreans figured out that if you took and did any decimals in there, like you did 1 over 3.2 instead of 1 over 3, that the number would not sound they would not sound good together. Like that kind of thing. Does that sound good together? No. You can tell when something sounds good together that that's a good fraction. So I just thought it was interesting that there's even fractions on the guitar. All right, we need to grade some homework. Would you take out last night's homework? Okay, we're back from grading homework, and we are going to do a little bit of review here. The fractions. To add fractions, you need a common denominator. Like these guys have a common denominator. These guys don't have a common denominator. If I wanted to have a common denominator here, I'd want to use like 14ths. So I'd multiply this one by 2 over 2, and that would give me 4 14ths. I'd multiply this one by 7 over 7. I can do that because I'm multiplying by 1. What happens if you want to find a common denominator and your things are like this? X plus 1 over x plus 2. Do they have a common denominator right now? No. What's the denominator on this x? It's a 1. How can I make it have the same denominator? Yes, sir. Yep, multiply it by what? X plus 2. And that way, the denominator now is x plus 2. And I multiplied it by the same thing on the top as on the bottom. So that kept it even. So now it's x times the 2, x squared plus 2x over x plus 2 plus 1 over x plus 2. Now they have a common denominator. And when they have a common denominator, you can just add the top and leave the bottom the same. All right, I'd like you to try one just like that. 3 over, we'll just say 3 over 1 plus 1 over x minus 4. Would you please add those together? First, you're going to have a common denominator. So what should the common denominator be? X minus 4. To do that, I put an x minus 4 here and here. And that's a big fraction, which equals 1, which is why it's okay. Final answer. 3x minus 12 plus 1. I'm kind of getting ahead of myself. All over x minus 4, and then this is all over x minus 4. And then the final answer, 3x minus 12, but plus 1 is minus 11, all over x minus 4. Raise your hand if you're understanding that and you're with me on that. Okay, good. Moving on. Besides finding common denominators on those fractions, the toughest ones were like this kind of thing. This actually isn't real bad because if you know the little trick, change it from a divide into a what? Into a multiply. And then I multiply by not 4/5, 5/4. And now it's a simple little multiply problem. Okay? But what happens if it's something like this? Well, you can find a common denominator up here and then get your new fraction, something over something. And then find a common denominator between these guys and get your new fraction. It just takes a while. You can do it. And then you got a fraction and a fraction, so you change it to a multiply by, flip it, and okay, it's all doable. Or you can be really smart and use that trick I just taught you that the calc teachers recommend, and that would be to multiply this by the common denominator of all of these guys. All of them would go into not 10, because 3 doesn't work. Not 15, because 2 doesn't work. 30. Now, the only tricky thing here is you got to remember this is in parentheses. So it's 30 times this. What's half of 30? 15. What's 2/3 of 30? 20. 15 plus the 20? 35. Over 4/5 of 30. Ooh, that's kind of brutal. I can do some canceling though. 5 and the 30, I can cancel. 5 goes in here once. 6 times 4 is 24. And then 1/3 of 30 is 10. 24 minus 10 is 14. There's my answer. So that calc teacher's trick is faster if you can handle it. But if you can't handle it, go back to just adding fractions, which is cheapers. You've been doing that since 2nd grade. And then do the flip and multiply deal. Okay? All right, enough about that. Please excuse my dear Aunt Sally. This is just a reminder that even some problems that look fairly easy, you can get them wrong if you do them in the wrong order. Like this problem right here. Each little individual part is easy. It's just what order should you do it in? Look at it close. What's first? And don't say the parentheses, because there's something in the parentheses that I actually need to do. The squared. Once I'm in the parentheses, because P stands for parentheses, I look at, of these two things, which one is higher priority, and exponents are next. So yeah, the 3 squared is first. Then, after you've done the one thing, you should stop and look at it again and say, okay, now what's first? Parentheses, right? But when within the parentheses, there's only one thing. So I do that. 12 minus the 9 is 3. And now what's first? The add, the divide, or the multiply? And so many kids think the multiply comes before divide because of this list. I really think maybe we should change it because they go, oh, multiply is before divide. Actually, multiply and divide are tied. And therefore, if they're tied in value, you go from left to right. And therefore, there's divide and there's multiply, and you go from left to right. So you go 36 divided by 4, which would be 9. 9 times 3 is 27. Now I've done all of that, and it's 27. And now it's 8 plus 27. And then I can get my answer. See how those can be tricky? Be very careful, and also don't fall into the trap that multiply comes before divide. It does not. Multiply and divide together go before add and subtract. But multiply and divide, you go from left. If it's a multiply or a divide you're picking from, they're tied, and you go from left to right. All right, moving on. Properties of exponents. I'm just going to fire a few rapid fire ones at you. Hopefully you'll recognize these. That's supposed to be an A. To the 5th, to the 2nd would be A to the 10th. A to the 3rd times A to the 5th. What would that be? A to the 8th. A to the 2nd over A. What would that be? A. How about A to the 2nd over A to the 8th? If these are supposed to be subtracted, shouldn't that be A to the negative 6th? Yes. But you're not allowed to leave negative exponents. So put a 1 on top, and it's 1 over what? A to the 6th. I tried to use the example yesterday of these are negative and they're not happy where they are. Put them in the other place. If they're on top, put them to the bottom and make them positive. All right? Okay. Next concept. Polynomials. Just some terminology. This is a polynomial because it's got lots of terms. How many terms does it have? 4 terms. This is not written in the right order. Which of them should have been written first? This one. Why? Because it's got the biggest what? Exponent, but we don't say that. We say that it has the biggest degree. Okay, this has a degree 3. This has degree 2. This has degree 1, because there's a little imaginary 1 there. And this is degree 0. Think of it this way. It's like there's a z to the 0 here. Okay, so that's to the 0 degree. What's z to the 0 mean? It means 1. So 12 times 1 will be 1. So you can always throw 1 on there if you're trying to figure out what degree it is. That's degree 0. That's degree 1. That's degree 2. That's degree 3. And you should have them in the order of the biggest to the smallest. Last thing for terminology-wise, if they ask you about a coefficient, that's the number in front of the variable. That's a coefficient, so is that, and so is that. And notice the negative goes on that 12. So the coefficient of that z to the 0 is a negative 12. Now technically there is no variable there, so we usually don't call that a coefficient. It's called a constant because it doesn't have a variable on it. Okay? So there's some terminology you should remember from your past. Moving on to factoring. If we start with the simplest of all factoring, It would be to take like 6 and say factor 6. That's what you would have done in 2nd grade. And probably 3rd grade. How would you factor 6? There's 2 different ways you could do it, but I'll choose the one you probably would have done. 2 times 3. That's factoring. Even though it's very simple, it is factoring. I broke it into 2 things that can be multiplied. All right. This is the kind you're more used to. 12x plus 3. Write that one down. Factor it, please. It might make it easier for you to see if I go like this. See, I broke the 12 into a 3 times 4, and now it's really obvious that there's a 3 in both of them. And what I'm doing is, just like before where I had the 6, I was breaking it into a 2 times the 3. I'm breaking it into 2 things being multiplied. There are 3 times all this stuff. So I got to make this a times problem. And that's where a lot of kids don't know what to put right here. What should you put right there? A 1. Because if this is really a times problem, 3 times 4x is supposed to make 12x. And 3 times the 1 gives us back the 3. Okay? All right, so that's simple factoring. How about more complicated factoring? X squared plus 3x plus 1. Let's say you had to factor that. You break it up into 2 things being multiplied. That's what a factor is. And then I say x, and then I say, okay, there's only pluses, so plus and plus. And the only way to make a 1 is with 1 times 1. But it's really important for you to check and make sure that it actually works. Does this one work? No. That makes x squared. That makes an x plus another x makes 2x. It's not 3x. That's what I needed. So this one doesn't work. So this is a fairly simple answer. This is not factorable. I just want to remind you, you're going to have ones that you're going to look at and go, I can't figure out how to factor this. It's because it can't be factored. There are ones that can't be factored. All right. Moving on to some more difficult kind of factoring ones. This kind right here is a particularly tough kind. I'd like you to write that down in your notebook. 3x to the third plus 15x squared minus 6x minus 30. It's got 4 parts. My first thought is whenever there's a hard one like this, always look for something that'll factor out of everything. Do you see it? Yes. 3 comes out of everything. And now my problem will become much simpler. X to the third plus 5x squared minus 3 out of that would make it 2x minus 3 times 10. Okay. Next, if it's got 4 parts, you got to go back to factor by grouping. This is something that you learned in higher algebra. I know you did. If you took that class, you learned this. Factor it into this part will factor, and this part here will factor. Okay, so 3. And then what factors out of this and this? X squared comes out. And what's left? X plus 5. Okay. And this one over here, what factors out? Be more specific, not just 2. Negative 2. Times what? Plus 5. And now it's got an x plus 5 in common. All right, this is getting too messy. If I can get rid of this down here, that'll help a lot. Okay. So now, I'm going to bring this down and rewrite it. I'm just going to like set this 3 aside for a second. Say x squared times x plus 5. And then negative 2 times x plus 5. Now here's the stretch. What's in common between these two? This is. So that can be factored out to the front now. Kind of like the 3 was factored out to the front. And now I have that x plus 5 goes in the front. And when I factor that out, what do I have left? This and that. And then that 3 I pulled out at the very beginning, there it is. Those are definitely the hardest. I'm going to do one more like that for you. Okay, I made up another one that you can try. Do that factor by grouping thing. What comes out of the first set? 2x. Oh wait, even more. 2x squared. And what's left when you do that? X minus 1. What comes out of the next 2? 3. And what's left? X minus 1. Then, do I have something in common here? Oh, yes, I do. That and that. So they come out to the front. And what do I have left? If I yank both of those out, I have 2x squared plus 3 left. Raise your hand if you had that one right. All right. You did this last year. It's just you need to remember it now. All right. Now, my difference of squares is another kind of factoring that's really simple if you remember it. You take the square root of this and the square root of that. It only works if they're perfect squares. That's why we say squares. And the square root of x squared is x. The square root of 16 is 4. X plus 4, x minus 4. Remember that? That's an easy kind. All right, what if it's 4x squared minus 144? Is this a perfect square? Yes, it is. Is that a perfect square? Yes, it is. So I can go 2x and 2x. And then 144 gives me 12 and 12. And then what do I do? Plus the minus. Now some of you might be thinking, wait a minute, there's a 2 in this and there's a 2 in that. You could have factored that out. That's true. That would have been smart. But what happened is the 2 is still buried in here and here. So I can factor it out at the end if I want to. So that 2 can come out, and I'll still have 2x plus 12 here. And this one becomes 2, and then x minus 6. And then this one can have a 2 factor out also. 2 can come out, and what do I have left? X plus 6. And then I have a 2, and then x minus 6. And then that can come to the front and make a 4, x plus 6, x minus 6. But it would have been smarter if you'd have known in the first place that 4 times 36 makes 144. And you would have noticed, oh, look, I can factor a 4 out at the very beginning. That'd have been smarter. So 4x squared minus, instead of 144, 36 times 4. I know you'd never know that, but you go back and think about it, it works. 4 comes out, x squared minus 36. And then it's just 4 comes out, and it's x plus 6, x minus 6. You get that? All right. So that's difference of squares. And the last part, it's hard. It's just a formula, though. If you write the formula, it's easy. If you don't have the formula in your notes, it's hard. I'm going to tell you, to save you time, that we're only going to be doing this kind on the worksheet, where it's adding 2 squares. But the formulas are exactly the same if you subtract cubes, sorry, I said square and I meant cubes. It's just that if you start with a minus, then you start your formula with a minus then a plus instead of a plus then a minus. So the only thing that's changed is where I put the arrows for the other one. But write down the one I put a box around. And now we'll be able to do this one, and you'll be able to do the one on your worksheet. And that is, this is a perfect cube. This also is, but it doesn't look like it. So I'm going to rewrite it. X to the third plus 5 to the third. Now it looks like a perfect cube. And now I can do my little trick. A and B are the things that I keep using over and over again in this formula. So all I got to do is make one small one and one big one. And in the small one, I put the two bases, x plus 5. And in the big one, I take the first one, the x, squared. Then I always do the opposite sign of whatever I started with. If I start with a plus, I use a minus. And then I use both of them, 5x. And then I use the last one squared. And that's always a positive right there in both formulas. So there's the factoring of that perfect cube. I want to remind you, it's the two bases with the same sign as the problem started with. Then it's the first one of the bases squared, both bases together, and then the other one of the bases squared. Now let's see if you can do one of these without your notes. Okay? X cubed plus, it's another perfect cube, 27. Small one, big one. First of all, you wouldn't really use 27. What would you use? 3 cubed. And now my bases are x and 3, so how do I start? X plus 3. And then you take the first one, and do you remember what to do? Square it. Then you use the opposite sign of the plus, so I use minus. And then I take both of them together, and then I take what? What's the last thing? Square the second one. 3 squared is 9. And that's always going to be positive. This is always positive. All right. It's easy if you have the formula for it, but man, that's hard to remember. All right. You're done. Now you got to put some time to work. I encourage you to check your answers if you get stuck tonight. They're all doable. It's all factoring, stuff you've done before. The test is coming on Tuesday. So between now and then, you need to make sure you know all this stuff again. If you're behind, but you know it's not hopeless, you know you could catch up, well, then take the time and catch up. Learn this stuff again. Come in the mornings. I'm here Monday, Tuesday, Thursday, and Friday. The only day I'm not here, Wednesday in the morning. Okay, so if you ever want help, just come on in. And we can try to catch you up on what you missed. I ask that the first thing you do before you come in for help is that you check your answers on Blackboard. Because I don't really want to do homework problems when we've already taken the time to do them, write them all out, and post them for you. So check those first. Then ask me for help. Yes? Woo! That was loud. Sorry at home. I'm going to stop this.